In today's lab, we will be determining the percent water in a hydrated compound and the polarity of a water molecule, which makes it a great solvent for ionic compounds, causes water molecules to cling to the structure of solid substances. When this occurs, the trapped water molecules are called water of hydration, and they become an integral part of the crystal structure. There are many compounds that have a tendency to absorb water vapor from the air. These are said to be hygroscopic. In this experiment, you will test a copper-2 sulfate to determine its water of hydration. Although the water molecules are securely attached to the ionic solid that you will test, they are susceptible to removal by heat. You will gently heat a sample of the compound to drive off the water of hydration. By measuring the mass of the sample before and after heating, you can determine the amount of water in the sample and calculate its water of hydration. So the objectives of today's lab are to determine the water of hydration of a hygroscopic compound, specifically copper-2 sulfate, and then we will determine from that the chemical formula of a compound. The procedure that we're going to follow will be: first, we will measure and record the mass of a clean, dry crucible with its cover. Please do not wash the crucible at any time during today's lab. Then you will weigh out between 1 and 1.5 grams of the selected compound and place it in the crucible. It doesn't matter what your mass is, but you have to know the exact mass. Use a spatula to break up any large pieces of the substance by pressing the pieces against the wall of the crucible. Measure and record the mass of the crucible cover and the compound. Then set up a ring stand, ring, and clay triangle for heating the sample. Rest the crucible on the clay triangle, as shown. Tip the cover slightly so that it does not fit snugly on top of the crucible. Set up a lab burner, ignite the burner away from the crucible, and adjust the burner to get a small flame. Okay, we will be determining the mass of the crucible and cover, the mass of the crucible cover, and the hydrated sample. From the difference of these two, we will get the exact mass of our hydrated sample. Then, as described in the lab procedure, we will heat the crucible with its contents for about 10 minutes. The color of the sample will gradually change from blue to white as the water of hydration is driven out of the crucible. Then we will turn off the burner, cover the crucible, and allow the sample to cool for about 10 minutes. When the crucible is cool enough to handle safely, we will measure and record the mass of the crucible, cover, and contents. We will continue heating the crucible a second time with the contents for about 5 more minutes, then allow it to cool and record its mass in our report sheet. If the first and the second weighing agree within 0.05 grams, you can stop collecting data at this point. However, you will probably need to heat it a third time. So you'll heat it for 5 more minutes if this is necessary. Let it cool and weigh it. When you have 2 successive mass readings that are within 0.05 grams of each other, you can stop collecting data at this point. And now, finally, for the report. The calculations that we're going to be needing for today's lab come from Chapter 2, specifically on how to determine an empirical formula. First, you will determine the mass of the copper-2 sulfate and water in the sample. Then, we will determine the number of moles of copper-2 sulfate and water in the sample by dividing the mass by each molecular mass. Then, you will determine the simplest whole number ratio of copper-2 sulfate to water. And then you will round the simplest whole number ratio to get actual whole numbers, integers. And our final formula for the copper-2 sulfate ought to be CuSO4.xH2O, where we have determined the number X in today's lab. So in today's lab, we've used a rather simple experimental procedure in the lab to remove waters of hydration from the compound, and then from the masses of water driven off and the mass of the sample, we were able to determine the number of waters of hydration, essentially an empirical formula for this compound.